Enjoying a fresh poke bowl on this summer afternoon? Well, you have coastal upwelling to thank for that.
Upwelling is the oceanic process of the surfacing of denser, colder water from the bottom of the ocean. The warmer, less dense surface water is replenished with the rise of the deep ocean water and the rich nutrients it carries. Without this process, our food chain would collapse. Regions of coastal upwelling, although only comprising 5% of the total ocean, account for 25% of the total global marine fish catches. This is because upwelling allows the warmer, less dense surface water that becomes nutrient diminished with time to be replaced with the deep, nutritious cold water from the ocean depths. These nutrients fuel the production of phytoplankton, and as the bottom of the food chain, in turn, fuel the global marine system. In general, surface winds drive upwelling because of the friction the water creates when it interacts with the surface water, and how this, along with the Coriolis effect and the Ekman transport, move the surface waters that make space for the deep water to rise. In coastal upwelling, the deeper water is driven to the surface as the wind blows parallel to the land. This is where Ekman transport comes in. Ekman transport is the consequence of the interaction between the wind and water. The friction of the wind moving against the surface water drags the water forward, but because of the Coriolis effect, the water is deflected slightly and will actually move 45 degrees off of the wind's intended path. As the surface water moves, its movement creates friction with the layers, therefore dragging the layers of water beneath it as well. As each layer of water moves, the layer below is dragged along, veering slightly off from the intended course of the layer of the water above it. This creates an Ekman spiral. The Ekman spiral effect occurs until about 100 meters of depth, where the final layer of the ocean is dragged about a full rotated 180 degrees, or inverse from the wind's path. Yet, this all averages out to a net transport of only a full 90 degrees from the direction of the wind. The direction in which the water veers is determined by the Coriolis effect. In the northern hemisphere, the water is transported to the right, while the water is driven to the left in the southern hemisphere. In coastal upwelling, where the wind moves parallel to the surface of the land, the surface water is dragged away from the coast at a 90-degree angle because of the net transport effect of the Ekman spiral. Keep in mind, the Ekman spiral only occurs to about 100 meters of depth. So, as the lighter, denser, and warmer water is dragged away from shore, the waters at the depth of the ocean are unaffected by the driving forces of the surface winds and Coriolis effect. Therefore, as the space towards the coast is being created, the deeper, colder, denser, and more nutritious water rises to fill the gap.